Okay, so, well, thanks for joining me this afternoon. This session, well, everything really is in the title. What it is about hiding Android applications in images. You've got it right. So if you don't know what Android is, well, it's time to just run off, of course. That's the only prerequisite for the talk, actually. I am Axel. I'm working for Fortinet as an antivirus researcher. And this work is also done with Ange Albertini, who couldn't join us today at Black Hat. But he told me that he would be on Twitter if you want to tweet and ask him a few questions there. No problem. We'll go straight to the point. So what's this? Any idea? Okay, so, well, it's Anakin Skywalker, for Star Wars fan, and otherwise it's just an image, okay? I didn't expect that you'd see it. It's a PNG image, but that's what it is. And it's just a perfectly normal PNG image, normal header, displays all right, nothing really special with it. Except, of course, it's more than an image, it's also a valid Android application, provided you decrypt it with the right key. Okay, so the same image can also be a valid application. Why would we be doing this? Well, if we have a look at the adversary side, which is what we'll obviously do at Black Hat, just think if somebody has a malicious payload Android application, and then, well, he wants to make it invisible to the reverse engineer like me, and that's just a perfect way to do it, because whatever API call to Android or to Dalvik or whatever the text headers, things like that, everything of that will be invisible because it's encrypted. So you don't see anything at all. You don't see that there's an application, you don't see the resources, you don't see the assets, you don't see much except a picture. The only thing that you do see actually is, well, that image that I showed at the beginning of Anakin is a little bit fat. It's a 300 by 300 pixel, and it's like 500K for that. So that's a little bit kind of unusual. The other thing that you'll probably be seeing also is the code that is actually transforming that PNG image one way or another into to decrypt it and install the new payload application. But of course, this wrapping kind of mechanism can be obfuscated. You can use some known hacks like, using Dex class loader in Android to conceal that as well if you want. So, demo, if it works. So, I've got an Android emulator, which is gone over here. Come back here. There we go. That's just an Android emulator of 4.4.2. And that's my directory. In there, I have a makefile because I don't like to type too many long lines during a demo, and that's the only thing there's there. And then, well, my application, a proof of concept application. The goal of this proof of concept is just to show that I can really transform the image of Anakin into an application. We'll have a look at that proof of concept. We unzip it. It's really a standard tool. It's just a kind of script to do it a little bit quicker. I unzip it, and then I run a decompiler. In that case, it's Procyon decompiler, if you know about that one. Unzipping the application. There it goes. So, well, an Android package, you probably all know that it's just a zip. And inside there, we have, well, plenty of things, the Android manifest. In our case, we are interested in the assets. If If I go in there, I see that image, Anakin.png. It is an image, as file says, no problem. I can even give you a look of this one. And there we get, again, the image of Anakin. Okay, now we're going to have a look at the decompiled code, which is stored in the decompiled directory. So it's in there. There's just one file of interest, which is the POC activity, proof of concept activity. Very nice name. And it is very simple because, basically just one thing in the string there, the method on create that you can see there. I'm displaying a few stuff. That's not very interesting. I am reading the image Anakin.png and displaying it. Then there's a button, and if we click on the button, I read the assets Anakin.png, put that in a byte array, decrypt it with the key, mind you, Anakin equals dark side, okay? Write the result into a file and install that application, right? Just to show you that I'm not cheating for that proof of concept. That's all there is. Go back to the root directory, and I'm going to install the app. Hopefully it will work. So it's my laptop is a little bit slow, but it's a success. Cool. And that's the emulator. Maybe it's a bit small, so I've got the screen magnifier if you want to see it a bit better. There it is. That's the application I have just installed, POC activity, with kind of the not very nice icon of Anakin. I double click on that. It displays here the image, the PNG of Anakin. And if I click on the button, well, we have to wait a little bit, but eventually it will decrypt the image, see that that's an application, and install it. That's what we get. I say yes, install. And while I'm doing this is a little bit to see a little bit more. That's the payload inside, which has been decrypted and is going to be installed. Installed there. It's not that it's really intensive, but I think that my CPU is very quick. So there it is. It's installed, and we can even open it. So that's the payload application, which is completely hidden in the wrapper, and you've just installed Darth Vader, right? Okay. So notice that actually the image of Darth Vader, for instance, you couldn't see it in the zip of the initial wrapping application at all. No, so nothing visible there. So there it is, it works. And we'll go back here to the application center. Just to show you, last final thing is that we see now two different applications, the wrapping applications, that was the first one, and the one we've just installed there with Darth Vader. There, back to the slides. Oh, well, that's in case it crashed. It did not, so. I guess you were interested in it to see how it works. So there's 4 steps. First one is you've got, of course, to write your payload application, right? So there's no special limit to that. You write whatever you want. But then you've got to encrypt it. And you're going to encrypt it using a special tool that Ange implemented, which is called Angecryption. And we chose to have it look like Anakin Skywalker, but you can choose whatever PNG you like. If you want to have, I don't know, the image of Black Hat, it works as well, no problem. Then we do a little bit of hacking because it's Black Hat. And well, you implement whatever mechanism you can think of to install that PNG and decrypt it and install it whatever way you want. That's kind of besides the topic there. Right. So if we think a little bit of what we have to do, we have an Android package, which is the payload. So this is where we have Darth Vader. And we want that when we encrypt it to look like the image of Anakin Skywalker. So we have the plain text, and we want it to look like a specific ciphertext. So in other words, we want to control encryption. Is this possible? Well, at first sight, of course, it does not look possible because I don't know if you've ever tried, but whenever you change, I don't know, a single byte of a plain text or a single byte of a key, well, you get a ciphertext which is totally different. Here you've got on the left-hand side the plain text, and on the right-hand side the ciphertext. You see they look totally different, and there's absolutely no way that the ciphertext can look like a valid image. So it looks really difficult to control the output. And also it looks really difficult to see whenever you're changing a single byte in the plain text to see how much this is going to impact and where this is going to impact the ciphertext. So it looks really difficult. But of course, it is possible, otherwise I wouldn't be showing it, because there's a trick. We're using a trick there. The trick is that we are not exactly going to install the Darth Vader payload, exactly the one that we see, but something that will look the same to Android. And we are not going to display the image of Anakin Skywalker, but an image that will look like the same to our eyes. Okay? So by manipulating those small minor differences on the plain text and on the ciphertext, we manage to get something that matches with the key that we select. That's the way to do it. We use 4 tricks again. So I said that we have to do some tricks on the PNG to have something which is slightly different but that will look the same. What happens is that PNGs have, well, a header, and then all the information which is in it is built in chunks. So you've got like a header chunk, a data chunk, an end chunk, plenty of different chunks. What we do is that we are going to insert within the image a dummy chunk, a chunk with an identifier which is unknown. And what happens is that all image processing tools, when they see that dummy chunk, they just simply ignore it. So they'll say, oh, this is a header chunk, fine. This is what? Oh, this is an unknown chunk. I don't want to have a look at this. They go further on. And we can put some valuable information for us, but something which will not be displayed. And decrypt that to an application. On the other side, we've got, so the application, same thing. We want to modify it a little bit so that Android doesn't see the difference, but it gets useful to us. So Android packages are just zips. In a zip, if you want, you can just append data and it will be ignored. Same thing. You just have to make sure to put at the end of the zip a marker which is called the end of central directory to kind of say to zip into Android, this is the end of my zip file. Provided you do that, the zip will be valid and will be loaded, well, if it really looks like an Android application. The last two tricks are using a little bit of crypto, but it's really nothing really very difficult. No need to be like Shamir to understand that. So we are using, in this case, AES. It could be working with other block ciphers. And anyway, AES works block per block and on 16 byte blocks. In our case, of course, we've got far more than just those 16 bytes. So we have to use some chaining. There are plenty of known chainings, ECB, CBC, whatever. We'll be using CBC, which is cipher block chaining. In CBC, how it works is that the ciphertext for a given block consists in you take the result of the previous block and you XOR it with the plaintext of your current block. And that's how you get the ciphertext of the new block. So for the first block, you've got an issue because, well, you've got no previous block, so you're taking an initialization vector, the IV. Right. So again, in our case, we know our first blocks, the first 16 bytes of the Android application. That's the first 16 blocks of the plaintext. We also know the first 16 bytes of the ciphertext. That's the beginning of the Anakin Skywalker image. So we know what we want those to look like. We can select the key, Anakin equal dark side, or whatever you want to choose. And then, well, it's just pure and very simple equation. We just have to compute the IV that will match, that will work. And well, to do that, you just take the first ciphertext, decrypt it, XOR with the plaintext. And that will give you the IV that has the first two blocks match just perfectly well. So that's good for the first block. For the other blocks, we are using another trick. It's really based on a very simple remark, which is that, well, whenever you are encrypting something that you have previously decrypted, you get back the identity, or reciprocally, if you're decrypting something you have just encrypted, you get back the initial plaintext. Otherwise, anyway, encryption would not be working. So, in our case, again, we just have to think that we want our ciphertext to look like the bitmaps, the pixels of Anakin Skywalker. So, how can we achieve that? Well, if we select our plaintext to be the decryption of those pixels, so like decrypt bitmap of Anakin, well, in that case, when we're going to re-encrypt it, it will be encrypt the decrypted bitmap of Anakin. And that equals, of course, the bitmap of Anakin Skywalker. So that's how we can get the result we want. So that's the last trick. And now we just have to pull all those 4 tricks all together, and we can have it working. So we have our Android application. Then we have the payload there with a Darth Vader application popping up. And then a central directory, because it's just trailing there to set the end of the initial application. And then we're going to append some data. We saw that Android would be ignoring all appended data afterwards. So that's data that we're going to put here. It's going to be basically what concerns the chunks of the image of Anakin Skywalker that we display in the PNG. In the PNG, same thing. For the first few bytes, the first 16 bytes, we have selected the IV so that they match perfectly well. And then we have a dummy chunk. In that dummy chunk, we're going to have actually the encrypted payload of the Darth Vader application that will be in there. And that will be skipped by the imaging tools because they'll see it's a dummy chunk that they ignore. And then when we encrypt the application, we're going to encrypt the appended data where we have the chunks of Anakin. We're going to use our fourth trick where we use decryption of encryption gives back the identity, and that gives us back all the bitmap of Anakin. And then we do we have a few remaining bytes there just to make sure that it's a multiple of 16 bytes and we have a trailing end of central directory, and it works. And those last few bytes are ignored because they appear at the end of the PNG file, and there. So that's how it works. It works, well, as you have seen, well, up to the Android versions, which are working now, 4.4.2. In June, we would notify the Android security team who fixed that, so it shouldn't be working in the next versions. However, we think that there's a slight bug in the way they fixed it, so we are following up the bug with them because I'm not sure it's totally working. The proof of concept that I showed has been released. It's not, I said here it would be soon after the conference, but actually I managed to push it just before. So if you want to have a look at the code, you can. You've got everything there. You've got also our Twitter feeds, and now I'm ready to take a few questions if there's time.